Hello, 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 everybody. We are back for some more moles continued. Today we're going to focus on compounds. So if we have a compound like this, magnesium nitrate, hopefully you remember the names. What do we do with that? How is it different? Well, a couple things are different. First of all, we have multiple elements involved, right? And secondly, we have these subscripts, multiple atoms of the same element. So first of all, one thing that we would like to do would be, most of the time you're going to have to find the molar mass, right? So if I want to know the molar mass of everything, remember, I'm going to do something like this. This is how I like to do it. This is how I taught you guys if you had me. List out the elements that you have. So magnesium, nitrogen, and oxygen, and get their individual molar masses. So magnesium would be 24.3, nitrogen would be 14.01, and then oxygen is 16. Again, those are straight from the periodic table. Then I'm going to multiply those by how many I have within, how many atoms of that element I have within the formula. So magnesium, I just have 1, so multiply that by 1. Nitrogen, remember this 2 goes to everything inside the parentheses, so I have 2 nitrogens. And then I have 2 times 3 oxygens, so it would be 6 oxygens. So this is 24.3, this would be 28.02, and then 16 times 6 is 96. And then you simply add them all up at the end, so 2, 3, what is that, 18, and this would be 148.32 grams per mole. So most likely in any kind of grams problem, you're going to have to do that. Again, not always, but most of the time you will. Okay. So what this means is that for every mole of magnesium nitrate you have, that is, the mass of that is 148.32. So now what do we do if we're given a problem like I have a 57.0 gram sample of magnesium nitrate. How many moles do I have? So from there we set up a dimensional analysis problem, and we're going to start with what's given. Always start with what's given, and then we do our, this is a one-step problem, and remember, in your conversion factor, you're going to always diagonally down goes the same unit. So this is going to be grams magnesium nitrate, and then this will be, I'm trying to get to moles, so moles magnesium nitrate. So now I simply, this is grams per mole, I simply use this molar mass and plug in the number. 148.32 grams will give me 1 mole. Now I solve. Multiply the top, 57 times 1, that's 57. And then divide by 148.32. So I'm going to put that in my calculator, 57 divided by 148.32. And I only get 3 sig figs here. So I'm going to get 0.384 moles Mg NO32. And there would be my answer. Now, what happens if I'm wanting to go to, if I'm given another problem, let's use the same, stay with magnesium nitrate. But let's say I have, in this case, let's say I have 100 grams of magnesium nitrate. Let's say 100, cross that out. Let's go 100.0 grams. so we can keep our sig figs. Magnesium nitrate. And I want to know how many particles of magnesium nitrate that is. So now, up here I was going grams to moles. Now I'm at grams, I need to get to particles. Well, in this case, I'm going to need, this is a two-step problem, because I need to go through moles, right? I have to go turn this grams into moles, and then turn the moles into particles, because there's no direct conversion between grams and particles. So here's how you would do it. 100 grams, always start with what's given, remember? Always, always, always start with your given number. And I know this is two steps because I have to go through moles. So again, diagonally down, that's going to be grams, MgNO32. And then I know this is moles, MgNO32, because that's how I'm going to get to particles. Then diagonally down goes the same thing. So this will be moles, MgNO32. And then I'm trying to get to particles. So what conversion do we have that goes from moles to particles? I'll give you a little time to think. What conversion do we have that goes from moles to particles? If you said Avogadro's number, then you are correct. So this is particles of MgNO3, 2. And I know that this is going to end up being Avogadro's number because I know that there's that many particles in 1 mole. What's going to go here? Well, this should be pretty much identical to this, since that's going to be our molar mass, how we get from grams to moles. Okay, so here's the setup. Now I do my math. I multiply the top, so 100 times 1 times Avogadro's number, 148 times 1, and then I divide my two answers. Divide the top by the bottom. So I'm going to do 100 times Avogadro's number, which will give me 6.02 times 10 to the 25th. And then I'm going to divide that by 148.32. So divided by 148.32. And that's going to get me 4.06 times 10 to the 23rd particles. And that would be my final answer. Okay. And again, if we were going the other way, let's say I had particles, I was trying to get to grams, I would basically just flip this all around, right? You'd have particles, instead of particles being here, they'd be here. Instead of molar mass being here, it'd be there. So basically you're flipping these two things, okay? Now, one last thing I want to bring to your attention. So if I have this many particles of MgNO32, right? What would happen if I asked you how many oxygen atoms do I have in this many particles, right? Well, let's look at the formula for a second. So if I have MgNO32, that means I have one Mg atom, I have 2 nitrogen atoms, and I have 6 oxygen atoms in every single one of these particles. So every time I have one of these particles, I have 1 Mg atom, 2 nitrogen atoms, 6 oxygen atoms. That's what this formula represents, right? So if I have this many particles of this, and I know that in every one of these I have this number of atoms of each of these, then how would I figure out how many oxygen atoms are in this many particles? Hopefully you're saying it out loud, even though I can't hear you because I'm recording this. But hopefully you said I would simply multiply 6 by how many particles I have, right? Because for every one of these particles I have 6 oxygens. So I'm going to do 4.06 times 10 to the 23rd particles. And I know that for every 1 particle, I have 6 oxygen atoms. So again, I'm simply just going to multiply across the top. Okay? So I'm going to do 4.06 times 10 to the 23rd times 6. And that would give me 2.44 times 10 to the 24th atoms of oxygen.